6.3, it's called the tangent ratio. Now, what is a tangent ratio? It has to do with triangles, right-angled triangles. And it has to do with the ratio between the sides. And we'll talk about that in a second. So, first we'll start with naming the sides of the right triangle. So this is a right angle triangle. They're both. The names of the triangle are based on which angle we're referencing. What does that mean? That means, well, this is always the opposite side of the right angle triangle we'll always refer to as the hypotenuse. Now, in reference to this angle, this side is called the opposite side. Now, if I was referencing this angle, then this side would be the opposite side. Right? But we're referencing this angle. We're referencing this angle right here. So, this side is the opposite side. In reference to this angle, what's this side called? That's called the adjacent side. Because it's adjacent. Adjacent means beside. Opposite, everyone knows what an opposite is. But adjacent, you might not know this English word. It just means next to. Now, in reference to this angle, if we're talking about this angle, then that's going to be opposite the angle. So that's the opposite side. And this side will be the adjacent side, because we're talking about this angle and it's right next to it. Now, the hypotenuse is also adjacent, but it's a special name. It's called the hypotenuse for a reason. And we'll reference it as the hypotenuse. These are all things you must know. You must know what the hypotenuse is in a right angle triangle. You have to know that the opposite side is in relation to the opposite side of the angle in reference, and the adjacent side will be the side that's right beside, right next to the reference angle. These are all terms that you have to get very familiar with. Now, let's look at the ratio. We all know that similar triangles, right? So let's look at these similar triangles. Okay. This triangle is similar to this triangle. They're both 90 here, and then they both share the same angle right there. Same with this. They're all similar. There's a 90-degree angle here. They all share the same angle, which means this is the same angle for all of them. Once again, when we look at this, that's a 90-degree angle. That is a shared angle, which means, 180 minus 90 minus whatever this is going to be this, 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 and this. That's why we say they're all the same. So that means the ratio, if we look at the ratio in reference to this, the opposite side over the adjacent side, AC, BC over AC, that ratio, because they're similar, is going to be the same thing, ratio to this. It's going to be the exact ratio, to be honest, over this, DE over AE, which means we're going to have the same ratio. It's going to be the same ratio. They're all the same ratio. The opposite side divided by the adjacent side is always going to be the same ratio. Also, they're increasing by the same rate. So for angle A, no matter what the size of the triangle, the ratio of, because we have the same triangles, but the ratio of opposite over adjacent is the same. That ratio is called the tangent ratio. So the tangent ratio, it says for any acute angle is any angle less than 90 degrees. That's the acute angle. That's an acute angle. Any angle less than 90 degrees. The tangent ratio is length of the side opposite angle A divided by length of the side adjacent angle A, or opposite over adjacent. Take the opposite side over the adjacent. And by the way, in a right triangle, it's very important that it's 90 degrees. So, using the calculator, find the tangent ratios of the following angles to the nearest thousands. So 40 degrees, let's do that. Actually, let's put up all the questions. Tan of 40 degrees. Whoops. So it's all a matter of learning how to use your calculator. Tan of 40 degrees. 839. 0.839. And of course, look, make sure your calculator says degree and not radians. 0.839. That's what we got here. Tan of 55. Let's try it. So tan of 55 equals 1.428. That's what we got. Try your calculator again for 73. Tan of 73 degrees. Tan of 73. So tan of 73, 3.27. Getting a little higher. That's right. And tan of 89. So tan of 89, 57.28. So it becomes very interesting to demonstrate the following. So follow along right now. We're about to show what the tangent ratio is about. Okay, so we have an angle. The adjacent side, we're going to make an angle. We're going to make a 90-degree angle right here. It's going to go up as high as possible. There we go. Now on this side I have about 10 millimeters, or one centimeter. So let's erase that and say I have 1 centimeter. Okay, now if I have a 40-degree angle, or give or take, I draw a 40-degree angle. These two sides are pretty similar. So if I take opposite over adjacent, it's pretty close. The angles are pretty close, right? So let's look at, it's close to 1. It's a little bit less than 1. But you see how tan of 40 is pretty close to 1? Now, let's say our angle is 55, which we just put it at 55 degrees. This side is almost 1.5 times this side. Let's draw that properly. So that one's 10 millimeters. And this side is about, well, it's about, oh wait, let's move it up. It's almost 15 millimeters. It's approximately 1.5, which is what we got over here. Let's switch it over to 73 millimeters. You notice as the millimeters get higher. And it's not exact because I'm not starting at the exact same spot. But now, let's see what it becomes. It becomes 1, 2, 3 and a bit. About 31 millimeters. Or 33.2 centimeters. 31 millimeters. Now let's look at when it says 89. I don't even know if I'll be able to draw 89 on this. There we go, 89. Does it ever get closer? It's almost 90. Anyway, the number is going to be 57, which we're not even going to be able to count that high. But let's just say, let's put an angle that we're going to actually reach the side. There we go. That's 85. And an angle that we can even count. So 85. Let's go on the edge. There. And where do we reach? Oh my God, it's hard to even place it. There we go. And we're at 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100 millimeters or 10 centimeters. 10 centimeters. Okay, so let's say that 85, right? 10 of 85. What are we going to end up getting? Close to 10 centimeters? 10 of 85. Approximately 11. Like I said, our calculations are not exact. But you see how as the angle gets closer to 90, the tan ratio is getting larger. It's just increasing. The opposite side's growing significantly faster as we approach 90. So if the ratios are set based on the angle, then I can find angle if I have the ratios. Find the angle measures to the following tangent ratio to the nearest angle. So it's saying, what's the angle, angle A, when the tangent ratio is 1.7, which means 1.7 opposite over adjacent equals 1.782, which means the opposite is about 70% larger, or 1.7 larger than the adjacent. That's my adjacent angle. And my opposite, if my adjacent was 1, my opposite would be 1.782. Now, let's see what that translates into. If I have a tangent ratio of 1.782, let's see if I can find the tangent. And everyone's calculator, of course, is different. We'll find it. Okay, so how are we going to do it on my calculator? 1.782. There we go. There's a tangent ratio. 10 minus 1. And we're going to put 1.782. It's basically 60.7. Is that what we get here? Yeah, 60.7 or 61. Clear markings. What does it mean when tan of B is equal to 50%? Well, then that means that if that's 1, that's my adjacent. Opposite's going to be half of that. So guess what? This is going to be less than 45 degrees. That's my guess. Let's try it in our calculator. 10 minus 1, 0.509. So how do I get it? I go 10 of minus 1. A lot of you will have a second function. 10 of minus 1. What's the value? 0.509. 0.509. Is that right? Anyway, I get about 27 degrees, which is what I get here. That's a check. What if it was 6.89, which means if this is 1, whoops, if this is 1, it's going to be 6 times that. In fact, almost 7 times that. It's going to be a very big angle. Sorry for the triangles, ugly triangles, but it's just to demonstrate a point. Okay, so 6.895. Clear. 10 minus 1, 6.895. Is that what the number was? Yes, 6.895. I get an angle of 81 degrees. And that makes sense. Approximately 82 degrees. Okay, and that makes sense. What does that mean? That means the opposite is 6 times greater than the adjacent. We can only get that with a really large angle. That's 6 and that's 1, or 6.85, and that would be 1. Right? And of course, if it's 0.063, well, that means if this is 1, this is going to be very, very small. So it's going to be close to 0. Let's see how it works out. 0.063. Clear? Sorry, we should go 10 minus 1. 0.063. And we end up getting an angle of 3.6 degrees, or 4. So we can use this to apply it to our, we all know we can find this side with Pythagorean theorem, but how do we find this angle? Well, we can use our tangent ratio. We can use tan of P equals opposite over adjacent. What's the opposite? 5. What's the adjacent? 8. So 5 over 8. Now we put this in our calculator. 10 of minus 1, 5 over 8 will get 52. So let's just try it. 5 over 8. Close brackets. Whoops. 32 degrees. So that's 32 degrees. What about if we want R? Well, now my opposite is 8. And my adjacent is 5. Opposite over adjacent. Now, how do we get that? We just take the tan minus 1. Right? We take tan minus 1 of 8 over 5. Put that in the calculator and we get 58. Let's try it. So let's say tan minus 1 of 5 divided by 8. Close my brackets. Oops. We should close my brackets on the outside. Oh, is it 5 over 8? It was 8 over 5. The opposite. Or not the opposite, but anyway, the answer is 58. And that's how we got 58. Of course, wouldn't be complete without giving you a word problem. From a point on the ground, 30 centimeters. So the first step is we have a ground and we have a tower. And 30 centimeters, 30 meters from the tower, the angle of elevation. Now, what's angle of elevation mean? If I'm a human, I can look straight. If I look up, that's my angle of elevation. I'll teach you now the angle of depression. This angle is the angle of depression. So it's the angle that goes down from looking straight ahead, the horizontal. So 30 meters from the foot of the tower, the angle of elevation to the top of the tower, so from straight to the top of the tower, the angle is 72 degrees. Find the height of the tower. Okay, basically that's my question. 72 degrees, 30 meters, what does that mean? Well, I have an adjacent and I want my opposite, and I have an angle. So tan of 72. Tan of 72 is the same for all angles with 72 degrees, right? Even if this was 60, the ratio would be the same. This increase would be the same thing as the increase from here to here. Let's clear markings. Okay, so my opposite is unknown. My adjacent is 30. My angle is 72. So what do? I take 30 times cross multiply equals opposite. Now this is how you write this. 30 times tan of 72, which means this is a number. Always remember, tan of 72 just corresponds to a constant number. Okay, we multiply a number by 30, which is 92.33. So how do we do that? 30 times tan of 72. 30 times tan of 72, close brackets, equals 92.33. So the height of the tower is 92.33. And there's your homework. I'll post it up shortly.